Hi, my name is Dalton Halbeck, and for the Expert TA problem this week, I had problem 3. This was the kickball problem. It's a 3-part problem. I'm going to go ahead and start with problem A. So, in the first problem, problem A, what you're looking for is the velocity of the ball. You have a few givens, which is your Vx, which is your velocity for the horizontal, and your Vy, which is your velocity for the vertical. This is 16.5 meters per second, and this is 12 meters per second. There's a few other givens too that we can note as well, is that there was that the acceleration, at least in the vertical direction, is negative 9.8 meters per second. We don't know theta, we don't know time, we don't know the x distance, so the horizontal distance that the ball goes, and we don't know the vertical distance that the ball goes as well. But just for this problem, they're only asking for the velocity of this vector, so right here, because we have this one and this one as well. So this is a basic Pythagorean theorem problem. So I just set it up as such. It's a squared plus b squared equals c squared, and then I just plugged and chugged from that point, really, because we had this side of the triangle and that side of the triangle. We were just looking for the hypotenuse and what the regular velocity was. So plugged in 16.5, 12.5, and then we had the c squared. I like to do my math not like beforehand. I like to do it as I go. It just helps keep me in order. So I had 272.25 for the 16.5 squared, and then 144 for the 12 squared. That still equals c squared. And then when you add those together, you get 416.25. And then you take the square root from the c, and you'll just square root that. And then so you get c is equal to v, which we're searching for here, and that's a 20.4 meters per second. And then for part B, they are asking for the time that the ball is in the air completely. We can then add this velocity of 20.4 meters per second as our known, but we really don't need it because we're more or less dealing in the y direction. So we know that right here our velocity of y, which is our initial velocity, is 12 meters per second, and the velocity at the top of where we're looking for it to end will be velocity of 0. We know that when a ball gets to its peak point, the velocity is 0, though the acceleration isn't 0. So, but we do know the acceleration, which is the negative 9.5 meters per second squared, which is just gravity. And then we also know that we have a change in velocity as well. So I basically took the problem of acceleration. So I took a is equal to the change in velocity divided by time, and then I took the t and I multiplied it over here, and that allowed me to take the a and then multiply it over here, so I could get time equals the change in velocity divided by acceleration. So then when we come in and look at the problem, the change in velocity will be the final minus the initial. The initial is the 0, or the final is the 0, and the initial is the 12. So then, since we got to remember that we're going to have a negative acceleration, and so because of the math that's done here, we'll have negative 12 meters per second divided by negative 9.8 meters per second squared. And then that is 1.22 meters per second. Now, it's asking for the time that the ball is in the air the whole time. It doesn't say for one part, and the 1.22 meters per second is just from here to here. So then we have to double that for the entire flight, because it's going to be the same from here to here as it is from here to there. So from the ground to the peak, and then from the peak to the ground. So that gives us an answer of 2.44 meters per second squared, and that's your answer for part B of that problem. Then the last part of the problem, they're asking for how high the ball gets. Now you're able to add seconds into the equation, or into our knowns, and we're looking for y at this point. Now we know right here at the bottom that our y is equal to 0 because that's the starting point, because we're going from here to there. So we just take the basic this basic kinematic equation for y, and then when you look at it, your y naught's going to be 0, so I got rid of that there before I carried it into this problem. And so then I have y equals the initial velocity of y times t plus 1.5 times the acceleration times t squared. Now, the thing to remember is when you're looking at this problem is, even though our total seconds is 2.44, we're only looking at 1/2 of this. So we need to make sure that the seconds that we use is 1.22 seconds, because it's time from here to here again. So that's what makes it real nice to know that and get this done before this. So then we just plug everything in. We'll have 12 meters per second times 1.22 seconds plus 1/2 times negative 9.8 meters per second squared times 1.22 seconds squared. And then that brings us to where we had 14.4 meters plus negative 7.056 meters. The answer I came up with was 7.344 meters, and that's what I plugged in, and it was right. So the nice thing to know about these equations, and I found it in one of the learning modules online, was that when using this, because it's y, this is meters, because this is meters per second and seconds, this cancels out to be meters, and because this is meters per second squared and then seconds squared, that'll cancel out to be meters too. So when you're adding across, they're all going to be meters. Even if you don't have this and you actually have an initial here, it's still all going to be meters, and that's the point. So that's how I had the meters here and the meters there. That's it for my problem. Thank you for listening, and see you next time.